Welcome to another live stream from NBK Tech World. Let's continue our exploration of the SDL library. SDL2 can be used in game development. I'm going to be using the programming language C++. So this is picking up from something we already started. Let's just recap the previous session. I installed libsdl using my package manager. In my case, it's a Linux Ubuntu distribution. I did sudo apt install libsdl2, and I think there's a -2.0-so. Yeah. With that, there's a /ursl/include /sdl2. All the headers are there. The one we care about is this one, SDL.h. That can be included in our file if we do the angle brackets SDL2. That's the directory from usr/include, and SDL.h is the file we just mentioned. We learned to initialize SDL, create a window, and then paint that window blue. To do that, we did the following. We called SDL init, passed the subsystem we want to initialize. SDL init returns a non-zero value if any error occurs. Because of that, we do SDL log to log a message, and we use the SDL get error to obtain the error message, and that's replaced in the %s for the message that is logged. We use SDL create window to create a new window whose title is Hello World, position at the center of the screen, width 640, height 480. Check if the window, if anything went wrong, the window will be null, so we display an error message. I probably want to return some other error here from the main function, so I return 2 right now. I just added that. Finally, we take the window surface, that's a pointer to SDL surface, and we fill with a rectangle over the whole surface. Null here means fill the entire surface. And with the color blue, I did SDL map RGB using the format of the window surface with R0, G0, but B blue 255 in entire blue. Don't forget to use SDL update window surface to actually update the window surface, and we can see something. Because there's nothing in particular going on, we call SDL delay to pause the execution of the program by 5 seconds. That is 5,000 milliseconds. So we can see the blue screen. And then after that, the window is destroyed to free up memory space, destroy window. And finally, you have to shut down SDL with SDL quit. That's what we did. Now let's go on. Let's explore how to fill out rectangles, multiple rectangles on the screen. So what I want to do is try to make perhaps concentric rectangles. We already have the blue one. Can we make another one? So before updating the window, let's do SDL fill rect. Window surface. I don't want the entire one, so I need to define an area of the window surface on which I want to paint. To do that, we need to know about the SDL rect. So let's go into wiki. I'm going to look for SDL fill rect. And we have here the second argument, parameter SDL rect pointer. So let's create one. Say the screen is 640 by 480. If we want to make something, let's do half of the screen. How about that? Half of the screen width and height. So let's create a new SDL rect. Now to do that, look at the structure. SDL rect is, you can do it like this. It's a structure. You can set the X, Y, W, and H. Let's try. So I'm gonna call it rectangle 1. I can do rectangle 1 dot X is gonna be where I want to position X for this to start. Let's do 0, 0 for now. Rectangle 1 dot Y is 0. Now the width and height. Rectangle 1 dot width. We can type 3, the half of the 640 and half of the 480 here. Rectangle 1 dot height. That's 240. Or we could put that in a constant. That'll probably be better. Let's just try it out for now. Give the address of the rectangle 1 and give the color, right? SDL map RGB. Window surface format. Give the format of the window surface. Now we give the color. Let's do red. Red 255, green 0, blue 0. Let's try g++ main.cpp. And I forgot the linker, -l SDL2. Important to, if you use g++, the -l has to be after the .cpp files. If it's before, it doesn't work. Some mistake I did last time. A.out, let's see. Now you can see there's a red rectangle filled half the width and half the height of the screens, starting at 0, 0. Let's put these, the window height, width and height in a constant. So I'm gonna say int window width is 640, int window height is 480. With that, we can use this here in the create window. And we can use this here for the rectangle. Height divided by 2. Window width divided by 2. Let's try it out. No problem, right? Okay, so let's try moving the X and Y. How can we center that into the screen, for example? Mind you that the axis here starts from the top left. So X goes from top left to top right. Y goes from top left to bottom left. Right? So if I increase X to be, for example, 100, you should expect it to translate to the right. If you do Y 200, you expect it to translate where? Down, right? Because the 0, 0 is at the top left, X goes from top left to top right. Y goes from top left to bottom left. Let's try to center that red rectangle in the screen. The screen has a window width, right? Now, if I want to center that, I need to translate it by half of the width. Like I have to make sure. I could translate it to window width divided by 2, but what's gonna happen? It's gonna be in the wrong place. Let me remove the Y so we can start with just the X direction. Let's just centralize in the X direction. Now you can see if I do half the width, it's gonna go to the right hand side. How can we bring it to the center? Well, what if I do the following? I take the width of the actual rectangle. Now the width of the actual rectangle is window width divided by 2. So perhaps we want to put that in a variable to make it less confusing. Let me say, let's do the following. Let's do the width and height first. And then we can reference it here. So we can do the X. Let's translate it by rectangle.width divided by 2. What happened? Rectangle was not declared. Rectangle 1. Now it exactly matched the center. And that's because I used the width being half of the screen. Maybe let's try to make it less confusing. If the rectangle width was perhaps not half of the screen, but let's do a little more than half. Maybe 3/4. About that. If you do that, that's what you get. And that's not right? It's not centered. So how can we center that? Let me increase the delay so you can see more. So we have to bring it to the left. Let me think about that. If I had some way of drawing here. So if you shift that by the window width divided by 2, and then you subtract that width, what do we get? Not right. Let's see. So you have a rectangle here. And we wanna move to the center here. Here's the 0, 0. So we want to be able, half the screen is here. Let's say this is width divided by 2. By how much should I move this? So we center the rectangle in the horizontally. If I move by the width of the actual inner rectangle, it would move by what? Would be like here. That's wrong. If I move by half of the screen, it would be like here, which is also wrong. What if I move by half of the screen? and then I subtract half of the actual rectangle thing. That would go that way. It'll be like this. Let's try that. So take the width of the screen, divide by 2, and subtract half of the width of the rectangle. And now it's centered. You can do the same for the Y. You can do the window height divided by 2 minus rectangle 1 dot height divided by 2. And if you want, you can refactor that. Now it's centered. You can simplify this, right? Both are divided by 2, so maybe you want to do window width minus rectangle width and divide by 2. Window height minus rectangle height and divide by 2. That should be the same. There you go. Let's make the height, let's increase that to 3/4, so it takes more space up in the bottom. And let's make more concentric rectangles. You can see now it's like that. Let's make more inner rectangles, maybe 2 more. So essentially I'm doing the same thing. I have to define SDL rect for rectangle 2, and I have to define the width and the height. Rectangle 2.width. In this case would be, let's do, instead of 3/4, let's do actually half of the screen. Window width divided by 2, rectangle 2.height, window height divided by 2. And then you do the same procedure here essentially. You just copy and paste. And you change this to 2. You can see I could start making a loop and making reusable functions for this. And then you do the same thing again, right? Call SDL fill rect. You have to give the surface you want to paint on, in this case window surface. And then you give the address, right? Because it expects a pointer to SDL rect of a rectangle 2. This is rectangle 2 defines the area of the surface that we want to paint. And this is the area like in the inner area. Then you give the color. You can get a color using the SDL map RGB. Give the format of the window surface and the surface dash greater than format, and give the color. Let's do red, green. Let's do green. So 0 to 55, 0. So red is 0, green is 255 full, and blue is 0. With that, we can do the thing again. And what happened? Something happened there. Oh, it didn't work because I put 1 here. I forgot to change this to 2. Let's try again. There you go. Now there's a green inside. Anyways, I think you get the point. It's just the same thing over and over and over. If you you can make some kind of inner concentric rectangles if you make a loop. That would be kind of cool. Nice exercise you could do. Essentially, you just loop and keep painting rectangles inside and smaller. And here's the code. Just keep doing the same thing over and over. Now this is cool and all, but let's try to get user input. Let's try painting some rectangle that moves on the screen. That's like a precursor to a player moving on the screen as you press the keyboard. That's something interesting. To do that, we have to deal events. SDL events. So this is what we're gonna use. So they say you have to pull the events, and then you figure out what to do based on what the user typed or whatever they did. So to do that, let's do the following here. So we're gonna have to have some sort of game loop so it doesn't quit. And then we're gonna handle the quit. And then we're gonna handle user input, maybe the keyboard errors. Okay, so we're gonna do the following. We're gonna create an event up here. Let's do it here. After all these rectangles. SDL event. Let's call it event. Now I have to figure out the game loop right now because it's just quitting the application. So let's do the following. Let's make a bool here. Let's figure out. Let's do quit false. Let's assume the user doesn't want to leave the program just yet. So as long as user doesn't want to quit, not quit, right? While not quit. Eventually the user is going to quit, so we have to set quit to true so it exits. Otherwise it's going to be repeating forever, right? Infinite loop. Now, while we're there, we can start painting stuff. As we did before, we can create the window, it's fine. We have the surface of the window. Maybe I want to get this fill rect and whatnot. I want to keep repainting all the time. So this I want to move into the loop. Let's move that inside. Because it's going to repaint all the time. Now, with that, I want to check for input. Let's figure out. We could check after the painting or before. Maybe I should do it before. How about that? So before that, I'm gonna pull the event. So I'm gonna use SDL pull event. You give the address of your event variable. Okay. Now when you do this, it returns some value. If the value is non-zero, that means the user inputs something. So this you check if it's not zero. So you're gonna go through all the events. So while full event. So you're gonna check what's the event type. So let's say the quit one. If event.type is this constant SDL quit, we're gonna set quit to true. Okay. And then with that, we can paint something and then it quits. It stops the loop. The surface update should be inside the loop too. There's no more need for delay, so we can comment that out and remove later. Let's think about this. So quit is while, as long as the user doesn't want to quit, go through all the events. Input, for example. See if the user want to quit. If so, quit is true. That's the only event we have right now. We're only handling that. And then paint whatever, update the surface, keeps repeating. Check events, any events, paint, update window surface. Check events, paint, check events, paint, until finally, eventually, the user wants to quit. Let's try that. So you can see now it stays there because it's continually panning. So the program doesn't exit at all. If I click this X, it exits. And that's one signal, right? SDL quit. That's the one way you can quit. By clicking the X in your graphical user interface. Now let's make a small rectangle to indicate it's the user, the player, right? So what I'm gonna do is make an SDL rec here for player position. So player position, I can initialize. Maybe I can do like this. Let's do 0, 0, 32, 32. SDL fill rec, Windows surface, at player position, SDL map RGB. What's the color of the user? We can make it outside. Let's do, let me figure out what the type of color is. SDL map RGB. It returns uwint 32. So uwint 32 is the type. Player color. Let's do SDL map RGB. Windows surface format color. Choose whatever you want. Maybe you can do some sort of combination. I don't know. Let's try something random. I'll do 128, 128, 128. And then you pass that player color. Let's see what we get. See, the player is this square here in the top left. And that's what we're going to use to move around. So we want to handle input so that the square moves to the right, moves to down, and so on. Let's do that. So we're going to have the polling of events. We got to check, is there a keyboard, right? Event. Let's think about that. So let's do an else if. Else if the event type was SDL key down, meaning you press the key down in the keyboard. Now there could be any key, right? So you gotta figure out which key. Depending on the key you pressed, you can do something about it. So if the event key.key.keysim.sim, okay, it's kind of long, is, let's say you pressed to the right arrow key. Let's do SDL k underscore right. If that was the right arrow key was pressed down, we do something. Let's try to move that rectangle. Now we need to put player position somewhere stored. We want to update player position. But we don't have the variable here. The variable is later, comes later. So we want to bring that up there. So instead of having it here, I'm going to bring it up and having it at the beginning. Actually, even outside the loop. We don't have to redefine every time. So put it outside. And we can say that player position.x, we can add it's equal player position x plus, because you're going to the right? We need to increase some amount. Let's increase the amount of the step. Let's see its own width, could be one way. I know it's 32 right now, so maybe you can do that. 32. Let's try. So let me quit my program here. Where is it? Press right. You can see I'm pressing the right arrow key and it goes to the right. You can see it goes really fast if you keep holding it, right? If you hold it, it goes really fast. Let's do that for the bottom, going down. Let's do together. So what would you do here? There's already the case for right. How would you do for the down? Else if event key sim.sim double equals SDL key down player position dot y equals player position dot y as it is plus 32 because the axis goes down the screen. Press the down arrow key and it goes down. Press the right, so on. Nice. Now we can't go left, we can't go top to the up. Let's do that too. So it's just the same thing, just copy, right? Else if event.key.keysim.sim is SDL k left player position dot x subtract, right, equals player position dot x minus 32. Else if, let's do the up, event keysim dot sim SDL k up player position what dot y equals player position dot y. Now be careful here. What is it gonna be? If you're going up and the axis goes down, you have to subtract minus 32. Now you can try going right, down, now go left, now go up. Okay, now it works. Okay. Now that's very nice, but see what's gonna happen. Look at this. It went off the screen when I press right. We have to figure out a way to prevent the player from going out of bounds. Oops, he went up. Oh, it's off the screen, and so on. So we have to cap the position. Let's do that. For if you're going right and the last position at the right is the width of the screen minus the width of the player. So we cannot allow more than that. So for the going right, you're gonna check, right? You can do this. So there's two ways. You can first do the calculation and then check right away. Or you can calculate and change the value first and then revert the value back if you go out of bounds. Either way is fine. So for example, let's do a pre-check and not change anything unless you're still in bounds. So for that, let me put it here. So we're looking at this gray player thing and we're figuring out the out of bounds here. We don't want the player to go out of bounds. So if you take the player position X and you add 32 and this goes greater than or equal to, right, the window width. Well, got the window width. Let me show you here. Let me do another. So we got the whole screen and you're here. And this is what? This is the window width, right? Minus the player width. So if you try to go here, out of bounds. So that means that your X for the player is right at the X for the width of the whole screen. So that's why I do that. If that is the case, I don't want to do anything. So I should actually be handling just the case where this is still less than the window width. In that case, I would still do the calculation. Let me see if that was working. So now I'm gonna go to the right. I'm gonna press right until I reach the last tile, right? Now I'm the last one. I'm gonna try going right again. I cannot. I'm pressing the right arrow. It doesn't work because of that check, right? The check says if I add 32 right now, if I add 32 and that's less than the width of the, if that is greater, right? Greater than or equal right here, then it won't do anything. This will have been false and the position will not change. We have to do this the same for going up and for going down and for going to the left. So we can cap. So let's do that. Essentially the same pattern. We only do the calculation, the computation here and change the value if it doesn't go out of bounds. So for going down, you're right here. You don't want this to happen, right? I'm pressing down and it goes beyond out of bounds. So if player position dot y plus 32, right? I need it to be, as long as it's less than the window height, I am fine. And I'm always assuming that the step is fixed, okay? If it weren't fixed, we would have to make a better computation because you had partial outer bounds, right? Part of the player would be out of bounds. So you gotta be careful. I'm making an assumption that the steps are 32 pixels, okay? Save it, let's try again. Wait. I'm going, we did down, right? Okay, it's not, it's fine now. I'm pressing down, 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 now it doesn't go. Let's do for the other ones. If player position dot x minus 32, as long as this is greater than 0 this time, right? Because 0 is the beginning of the screen there. As long as it's greater than 0, we're good. Save it, close here. Oops, seems like I messed up something. Why? Why does this happen? Because I subtracted 32, right? I'm trying to go to the left. I subtract 32. That means the player is now at position 0. But position 0 is fine, actually. That's the beginning. So I need to have a greater than or equal to. If it's equal to 0, that's fine as well. Try again. I'm pressing left, it doesn't go. Do the same now for up. If player position dot y minus 32 is still greater than or equal to 0, that's totally okay. Close this, recompile and execute. Going down, going up, going left, going right. So we're capped, we're within bounds, we cannot get out of bounds now. All right. So with that, I think this is gonna be the end of this live. Let's recap everything we did. We learned how to paint more rectangles in the window surface. We learned about creating an SDL rect to define an area, a specific area of the surface on which we want to paint. SDL rect is a structure. You can define the W for width, H for height, X for X coordinate, Y for Y coordinate. We learned to make a computation to centralize in the horizontal and vertical. If we got the width or height of the screen, subtract the width or height of the object and take that divided by 2. We learned to define a position for the player And we added the game loop that once you click the X, it will quit for us. Now the program continuously paints and doesn't exit until we tell it to do so. We learn how to handle events with the SDL pull event. Create an SDL event and then we give the address. As long as it's not greater than 0, that means there's something there we have to process. And we process now the key down events, meaning the user pressed down a key in the keyboard. In this case, we handle the arrow keys, right, left, up, and down. And then what we do is we change the position of the player depending on the key that was pressed. And that is reflected now in the application program. The gray rectangle or square represents the player, and he can now move around. We also learn how to cap the player to the bounds of the screen so it doesn't go out of bounds. So we can no longer go out of bounds if you try to do so. All right. So that's it, and I hope to see you next time. Goodbye.